So, hello everyone. In this video, we are going to take a look at the inequalities, and we're going to look at different methods to solve these inequalities. So the key moment in solving these is to really understand what the absolute value mean. Of course, it's important to understand that if you have one in the inequality. So let's take an example at example 8 here. So it says that let's choose this brownish color. So 2 times the absolute value of x plus 3, which is less or equal than 10. So what does it really mean? We have this number line here, and this line represents a 0 in this. And this is the direction it increments or increases. So we know that the absolute value means the distance from 0. Distance from 0, obviously in the timeline number line. So let's make a few changes in the inequality equation. So let's divide by 2 because we have a multiplication by 2. So let's divide by 2 both sides, don't forget about that. And if you do that, you will be left with x plus 3, absolute value of x plus 3 on the left hand side, which is still less or equal than 5 because 10 over 2 is 5. So it means that we can show the distance from 0 of x plus 3. So we know that the distance from 0 of x plus 3 is not more than 5, but it can be 5. So let's just write with white. So let's say that minus 5 is here, and approximately 5 is somewhere maybe here approximately. So this inequation allows us, or the inequation to so this relation allows the inequality to be equal to 5, which means that we can put these solid circles here, which indicates that 5 is in the range. Range, I mean the set of numbers that can be solutions. So yes. It means that the distance cannot be greater than 5. So what do I mean by distance? This is the start point, 0. You start counting from this point. This is distance 1 because you've gone one step away. This is 2 steps. This is 3 steps, 4 steps, and 5 steps, and here we are at -5. So it basically means that this distance is equal to 5. This relation indicates that it cannot be greater than 5, only equal or less than 5. So we draw a line here. It means that the distance is not greater than 5, so equal or less than 5. And the same on the other side of the number line. So yeah, basically that is the solution of x plus 3. Now the strategy here is we try to put these lines into mathematical forms. And in the mathematical form, I mean like from minus infinity to 5 closed brackets. That's just an example. So we've got to get to these kind of form from the lines. How can we do that? So let's see this line here, which I'm going to enlight with blue. It goes from minus 5 and it has a solid circle here, which means that we put a closed bracket here from minus 5 itself included to 0. Let's do the same with the other side, which is broadened with red, bolded, sorry. So it goes from 0 to 5. But we can combine these two together and say, well, it's basically the range from minus 5 to, or the territory from minus 5 to 5 exactly. So that is the solution of what? Of x plus 3. So let's just stick to these two and say and separate them and say that basically, I said this line represents not x. No, not x. But what? X plus 3. So we can say that x plus 3 is, it says it is greater than minus 5. Why? Because we are starting counting from negative 5 to the positive infinity, so greater or equal than 5. And on the other side, we have x plus 3 is smaller, less or equal than positive 5, right? Because it goes from here to there. Basic stuff. So let's solve these inequalities, and we subtract 3. So we are left with x is greater or equal than negative 2. That's great. And on the other side, we have again subtract 3 by 3. X is less or equal than 2. These are the solutions, and we can draw a number line again to illustrate the solutions. So we have 0 here, we have negative 2 here, we have 2 here, this is x. So x is greater or equal than negative 2. So I indicate that with, first of all, a solid circle because it can be equal as well, and greater than this. So let's just draw a line here. Okay, but on the other hand, x also has to be smaller, less or equal than 2. So equal, so it is a solid circle, and again, smaller than 2, so from 2 to negative infinity. And the intersection of these lines are the solutions. So everything that is between negative 2 and 2 is the element of the range of the solutions. Yeah, because I forgot to include that the x is the element of real numbers. So everything between negative infinity to infinity. It means real numbers. Okay. So yeah, that was the task 8 or example 8. Let's take a look at an easier one. Well, not particularly easier, but somewhat easier. 13. And that is minus x minus 1 to the power of 2 or squared plus 4, which is greater or equal to absolute value of x plus 2 minus 1. And now I realize that I should have solved this the graphical method. So yeah, never mind. We've solved the first one in the algebraic method. Which is not a problem because we are also going to graph it later if we solve this at first. Oops, again. Yep. Okay. So let's just draw a coordinate system real quick. Somewhere here and do another one somewhere here. And yeah, this is the x-axis, y-axis. This is 0 here. We have numbers up until 5 on each side, on each axis. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. About just the right distance from each element. So it's negative x minus 1 squared plus 3. So it means that this is going to be a parabolic diagram or graph with some sorts of changes in it. It is shifted up on the y-axis with 4. So here, shifted up and shifted left, but not left, because if it is negative, we have to take its minus 1 multiplicated number value. So it's opposite. So if it is negative inside the bracket, we always have to say, well, it is positive, in fact. So it is shifted in the right direction with 1, which intersects 1 point here, and that is the new point, starting point we have. And we have this negative 1 here. It's multiplicated with negative 1, which means that the parabola is sad. There's a sad emoji. Yeah, so it's going down. Okay, so in this point, we have to show this x minus x squared in this point here. So here we have minus x squared. That's what we have to illustrate. Okay, so if we do not know the values, let's just write or draw a table again. Maybe not here, but let's do it here. Okay, so x, y values, and let's say we have 1. Then y is going to be equal to what? Well, we just insert 1 into the place of x, so it's going to be 1 minus 1 squared. So 1 squared is 1, negative times negative 1, that's negative 1. 2 is going to be negative 4, a little bit negative numbers, minus 2. So we put minus 2 here, or negative 2 to the square, that's 4 times negative, that's again negative. So let's just indicate these points in this coordinate system. So 1, x1 is here, not here, okay, because this is the new starting point we have. So this is x1 in the new coordinate system, and the y is negative 1, it's here, okay? So that's 1 point here. Now the second one, x is 2, so that is somewhere here. And the y value is negative 4, so 1, 2, 3, 4, exactly on the x-axis here. Maybe I should indicate that with a red x here. Okay. The same on the other side. Negative 2 is 1, 2, x negative 2 is somewhere here, and the y value is negative 4, again on the x-axis. So somewhere, and this is a purple course here. And of course, 1 is again negative 1, so it's here. So it's going to look something like this on this side, something like this on this side. I have an app, GeoGebra or GeoGebra, I don't know the official pronunciation of that application, but or program, but I use that to illustrate these graphs. So that was the left-hand side. Left-hand side. Left-hand side. Let's do the right-hand side. So that is going to be x plus 2, absolute values, negative 1, plus 2 is here as well, which shifts the whole function, the x-axis to the left, because, you know, we have to take its opposite. So the starting point is not this, but minus 1 and 2 to the left, so here. So that is our new starting point. Okay, so now we can visualize, we can show the absolute value of x function starting from this point, which is just going to be a V shape, a letter V shape. But let's just show some points. So 1, 1 that is here, negative 1, 1 that is here. So something like this. Yes, here. It's probably totally wrong in this drawing, but yeah, I tried my best. So yeah, and the solution is where the two functions intersect. So this point, and somewhere here, we have to take those points, the x values of those points here and here. And those are going to be the solutions for x. And let me just quickly do that in GeoGebra, and I will insert the picture of these functions. So graph is here, um, with red we have the g of x function, which is the absolute value of x plus 2 minus 1. And we have the f of x function, which is minus 1 times x minus 1 squared plus 4, which is green here. So that is the function of f of x. The red one indicates the g of x. So we can see here clearly that the intersection, the points that where they meet, is B and A. And as I have already mentioned, we need only the x values of these points. You know, we always indicate coordinates like this in this order x and then y. So the first value is what we need. So one solution is -1, and the other solution is +2. And that's it. This is the solution. My illustration is not that nice, but it is similar. So yeah, solution 1 is -1, solution 2 is 2, and that's it. Are done. And as I have told you, we are also going to illustrate first example here, which is 2 times, sorry, let's just continue here, 2 times the absolute value of x plus 3, which has to be greater or equal than, oh yeah, we are not done. Never mind, I just finished this. X plus 3, which is, oh, not greater, less than, less or equal than 10. Let's just come back here for a moment. It says that, sorry, it's not x equals to -1. Almost. Yeah, so it's not okay. Almost. So this function, this here, this has to be greater or equal to this function. So basically, everything is a solution on the x axis that is to the right from this line. Okay, so everything that is in this territory is a solution. Everything. Okay, let me just show you this territory, not with my art work, but with the program. So turns out that the program cannot do that, but yeah, well, we just have to do this with my hand drawing. Maybe let's just use a ruler. And yeah, so everything from this point, from this line, sorry, from this line to the right is solution. So everything from -1, including -1, to positive infinity is solution of this equation. And you can just check that. Put in some values and try that out. So let's just solve this one with the graphical method as well. For that, let's just use quickly or draw quickly another coordinate system. Okay. Again, this is x, this is y-axis. This is 0 here, 1, 2, 3, 4, 5 here, 1, 2, 3, 4, 5 here, 1, 2, 1, 2, 3, 4, 5 here, 1, 2, 3, 4, 5 here. Okay, so I don't like this multiplication by 2, so let's just write we have to illustrate x plus 3, the absolute value of x plus 3, which has to be less or equal than 5. So basically we have y equals to this and another function which is equal to 5. Let's not say, but well, we shouldn't say that both of these are y. Let's say that the first is f of x, which is absolute value of x plus 3, and g of x, which is 5. And then we come back to this relation as well. Less or equal. Okay. So this is going to be orange or color or red. This is going to be color purple. So let's use this orange stuff. So x plus 3, but because of the plus 3, we can say that it shifts to the left by 3. So the new starting point is here, and we have to illustrate absolute value of x from this point, which is 1, and 1 is here, 1, 1 here, 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 so something like this. Again, it's not going to be perfect, but try my best. From the same point to this, so it is g of x. Let's do the purple one now, which is x plus 3 absolute value. Oh, that's what I've done right now. Sorry, that was f of x. Sorry. F of x. And the g of x is just 5. So yeah, that starts from here. And well, we can also write a g of x like this. Y equals to 5. So y is here, and it is always equal to 5. How can we do that? Well, that is constant line parallel with the x-axis. Sorry, I intended to do a purple line. Starting or always staying at height 5 on the y-axis. So where these meet, we have to look for the x coordinates of these points, point 1 and point 2. The coordinates of these, of course, point 1 is somewhere 6, 7, well, let's say that's negative 8. So point 1 is negative 8, and the y, of course, is 5 in both cases. So I can write that it is 5 here. And the x-axis, x value here, well, it must be 1, I think. So let me just do this quickly in the program. Okay, so I finally managed to do that. Here it is. So you can see that the absolute function is here, which was named to be f of x. Sorry, let's just use back. So f of x. This is g of x. So I was right with negative 8. And I wasn't right with 1. It is indeed 2. So it says, sorry. So that the absolute value has to be smaller and this on the x-axis, so smaller than 5, which is here, but the x value of this is basically 0. So it means that, well, everything that is to the left from this, from basically the y-axis, is a solution. So all the negative numbers here from 0 to the left are solutions of the equation. So the recording just stopped. I don't know why. So we have this example here, and I just said that this fraction has to be positive. Why? Because it says that it has to be greater or equal to 0. If I draw you a number line here, where 0 is here and that is x, what is greater than 0? Well, all these numbers, 1, 2, etc. So all the positive ones, all the positive numbers are here. So when is a fraction going to be positive? Well, if you divide a positive number with another positive number, or if you divide a negative number with another negative number. So let's just do experiments and see when is that going to happen, in what kind of axis, what kind of cases of axis. So let's do the first example. It says that both the denominators and denominators are going to be positive. So I know that 4 times x minus 3 has to be greater or equal than 0, and also 3 times x plus 1 has to be greater or equal than 0. And if you solve these, you will get x is greater or equal to 3/4, and here you will get that x is equal to not equal, but greater or equal than -1/3. So these are the solutions here. So if x is greater or equal than 3/3 and greater than -1/3/3, that's totally fine. You will get positive numbers. But of course, we have to say that 3 times x plus 1 cannot be equal to 0. So we have to delete the equal sign from here, because the denominator cannot be 0. You cannot divide anything with 0. So you also have to delete or erase equal from here as well. So yes. So if you draw a number line for the first solution, -1/3 is somewhere here, 0 somewhere here. If 1 is here, then 3/4 are here, is here, and it can be equal, it cannot be, and these go like this. So the intersection of these two are the solutions so from this point to this. So the solutions of the first example here are numbers enclosed from 0.75 to positive infinity. That is the first solution we have. In the second example, and that's here, you have so both of these have to be negative numbers. So 4x minus 3 has to be negative, so small less or equal than 0, and the denominator has to be smaller less than 0. It cannot be equal because we cannot divide by 0. And if you solve these, you will just get x is less or equal than 3/4 and x is less or equal than negative 1/3. And if you want to illustrate that on a number line, you will see that let's say negative 1/3 is here, and if 1 is here, then 3/4 are here, is here, and so it can be equal, so it goes like this, and it goes like this. So the intersection is the solution. So remember that we have an empty hollow circle instead of a solid circle here. So the solutions in the second example are everything from negative infinity to negative 1/3, negative 1/3 opened, because that is hollow or empty. So these are the two solutions. You can write these down. Like the first solution is x is the element of the territorial range of 3/4 to from 3/4 to the positive infinity, and in the second case it's x element of negative infinity minus 1/3. And that's it. This is how you solve it. Yeah. So every time if you have 0 here on the other side of the inequation, you have to consider these examples. You have to ask yourself, does it have to be positive? Okay, when is a fraction going to be positive? If both the denominator and denominators are positive, and if both of them are negative. Okay. So this was the algebraic and graphical method, and maybe I will do a part 2 with further examples, but for now I wanted to do these examples, and well, I hope it was understandable. It happened to get a bit long. This video, I didn't want to, but I made a few mistakes, but this is how you learn. So I hope we will meet in the next video. Practice, do these examples by yourself again, change some numbers maybe if you are bored with the original examples. And I wish you all the best. Keep up the good work, and bye for now.